Hello everyone, welcome back to channel. In this video, we are going to deep dive into one of the most important topic in IP addressing, which is VLSM, which stands for Variable Length Subnet Masking. If you are preparing for CNA, Advanced Networking or the real world network designs, this video will finally make VLSM crystal clear. So stay till the end because we will be solving some real world VLSM design problem. Create a subnet tables and learn the exact step-by-step approaching using industry. Let's begin. Let's start with the VLSM definitions. VLSM is variable length subnet masking, which provide the ability to make more than one subnet mask within your major network. It allows you to further subnet your already subnetted network, which requires classless interdomain routing protocols. In simple word, what we can understand about VLSM is, without VLSM, all the subnet have the same size, but with VLSM, each subnet can have a different size depending on the requirement. Like this, designing room in a house of different size instead of making all the room equal. This is the big sentence you have to understand. For example, we are building a house and designing each and every room to the equal proportions is not reasonable, as if we design a room, kitchens, dining hall, toilet, we don't give them a equal amount of space, but we allocate the house for the different purpose, like toilet needed a small size and dining hall need a big little area. So this is a big differences between the without VLSM and VLSM. So you can easily understand by relating this with the real world examples. Okay, and what is the benefit of using VLSM? Like, it allows us to avoid IP wastage and use IP address more efficiently. If we compare with this real world scenario, as we are going to build a house and allocating the space to the different areas like bedroom, kitchens, toilet, bathroom, we do not give equal amount of space to each and every areas, but we will allocate the different size, okay, according to the purpose. Like toilet need a small area and dining hall need a bigger areas, so we can efficiently utilize the areas of the house, okay, in efficiently. Let's take other examples. This example is related with the networking, okay, and there are 4 networks and each and every networks have the different requirements of the host. Like network A need 100 hosts, network B need 50 hosts, network C need 10 hosts, and network D need 5 hosts. And without VLSM, what we'll be doing in the traditional subnetting, like we should be allocating all them to get a /24 IP, but they are the wastage of the IP. This is the not proper or efficient way of using IP addressing. Okay, so with VLSM we'll be solving these kinds of problem because we don't want to waste IPs. Okay, so we want to use the given addresses more efficiently. So understand why VLSM is important. Okay, VLSM important because it efficiently uses IP addresses. You can only allocate what is needed. Okay, and it is easily design the network hierarchy, so you can easily split network based on the real requirement. Routing protocols, like modern routing protocols like RIP version 2, EIGRP, OSPF, which fully supported VLSM, but in the legacy protocols like RIP version 1 do not support the VLSM. That's why RIP version 1 is outdated, as it doesn't support VLSMs. If you want to summarize, in short, without VLSM there will be the massive IP wastage, okay, but with VLSM there will be smart and optimizing IP planning, okay, and the efficient, as we already know that the VLSM advantage is efficient use of IP addresses. Okay, without VLSM, network will have to use the same subnet marks throughout the network, but all the network don't have the same number of hosts. Okay, let's take an example to understand these lines. Let's take examples like you have two LANs connected via serial point-to-point connections. Okay, each LAN has 50 hosts on it. When you assign the subnet marks, it has to be consistent across your networks. So you end up assigning a subnet class address to the one connection with the 62 host, where you only need 2. Are we getting this point? Okay. Instead of assigning 2 IPs, we will be assigning 62 hosts. So this is the waste of IP. Okay, this is not the smart and optimized ways of IP planning. So we will be using VLSM. With VLSM we can smart and optimize IP planning. Okay, smartly and optimize IP planning. And the greater capability of routing summarizations. Okay, although routing summarizations will be covered in the next videos, but routing summarization will be easily identified as we will be dividing each and every network on the basis of hierarchy, so we can easily summarize route summarizations. Okay, in these examples we will be taking that we have connected to the main site to the branch office. If we want to fix length subnet mask, we use 4 networks for the LAN and the 3 network for the one, and the total we need 7 networks. Okay, and let us say that we have a class C addresses of 200.200.200.0 assigned to us. If we need 7 network, we have to borrow 4 bit, giving us 14 networks, but it only give us 14 hosts per network. In order to get around this problem, we will be using VLSM. Okay, in VLSM we can get away with the borrowing only 3 bits. 3 bit give us 6 usable network within 30 hosts per network. We will use the first 4 network for our 4 LAN basing on the network, and subnet the 5th and 4th to give an additional network with the least host on the each of our 1 connections. Okay, our 1 connections only requires 2 hosts per network, and we need 3 networks. Let's do subnetting of the 200.200.200.0 network into 6 subnets. Okay, we borrow 3 bit, giving us a new max of 255.255.255.224 or the 27 bit sequence max. Okay, our new network will be like 200.200.200.32/27, and the 32 will be increasing added to the next network that will confirm about 200.200.200.64/27. That's why we'll gradually increase 96, 128, 160 and 192. And we will be assigning the first 4 network to our LAN based networks. We can take either the 5th or the 6th network and the further subnet it. Let's assume that 5th network and further subnet it. Okay, and the 5th network will be like 200.200.200.160, and we will be submitting this network. Like you can see, yes, I have divided the decimal number and the binary number. Okay, decimal number represent in the 200.200.200. Okay, as the remaining portion of 160 I have converted into the binary number. Okay, this one is the binary number, and we can easily check that the respective subnet marks, okay, of the given IP will be 225, as we already know that there is no changes in the third octet places. When you go to the left to the right, there is 255.255.255, and the 4th octet have been changing. So what we can do is like there is a 3 on bit and the remaining are the off bit, as we can say that network bit and host bit. Okay, 1 represent network bit, 0 represent the host bit. So 111 means, if you can see that in the first octet, second octet, third octet, there will be the like in first octet there will be the 1 byte is equal to 8 bit. So there is a 3 bit is equal to 8 3 is 24. Total 24 bit is given, and after 24 we can add 3 bit, as the 3 is the on bit. Okay, here you can see there is a 111. So 24, 25, 26, 27, and 27/27 is 128, 192 and 224. Like here we can say that new subnet marks will be like 255.255.255.255.224. Did you get it, guys? We only need 2 hosts per one connection. We will borrow for the 3 bit from this network, or leaving only 2 bit from host on each network. Like we again will be receiving 2 bit, and the network's number are as follows. We can see here 200.200.200. You can see, and the given informations like some of the bit are never changed. You can see that 200.200.200, and we will be seeing that 101 in all the sequence is the same. Okay, there is sequence and the same. You can easily identify. You can check that. Okay, and I have already bold the binary number. Okay, this stands for, okay, this stands for 200. Like this example, like 200.200.200. Let's take first one. Okay, 200.200.200.101.0010, which stand for, if you convert this binary number into decimal number, it will be 164. Okay, valid host range will be 65 to 67, as we only required 2. Okay, as we can go on like 164, 168, 172, 176, 180 and 184. There will be, and the values of host range will be like you can see that 65 to 67, 69 to 70, and as on. Okay, so you can choose any three of the above network address for the one connection, because there is only 2 connections, so we only need 2 usable IP. Okay, and this is the final network or the IP I have assigned as the requirement. Okay, like, as you can see that, as you can compare the given initial problem. This is the initial problem. Okay, this is the initial problem. After solving this problem, I have identified and given the each and every IPs required by the networks. Okay, in the one connection we only require 2 IPs, so we have used /30. Okay, /30 means we only require only 2 IP to connecting the series connections of between the ones connections. Okay, but inside the network there will be like a different kind of, if there is a different requirement, and so we will be using different notations as the requirement are the same, is 25 host, 25 host, 25 host, 25 host, so we have used the slash notations is 27. Okay, we can easily see here. So I hope you guys have understand the VLSMs. So don't worry about that one. I'm giving you the another problem, like creating VLSM. There is the task 1. Okay, and the initially we have the same host like 25, 25, 25, but in this problem I have given you the different requirement of the host, like the 2 network will be using 25 host, and the remaining 3 will be using 5 host, and will 1 2 3 4, there is a 4 one connections, series connections. We will be using using 2 IPs. Okay, and there is an objective like given IP address of 200.1.1.0, use VLSM to assign IP addresses in an efficient manner by minimizing loss of host addresses. Okay, write the network addresses of all the network including one connections. Make sure to write the subnet marks in the bit form /24. This is the given IP. This is the given IP. So you have to do VLSM according to the requirement. Yes, you can see there is a 25, 5, 5, 5, and 25 means like 1, 2, 3, 4, 5 networks. Okay, and 5 internal LAN networks, and there is a 1 connections 1, 2, 3, 4, like 4 1 connections, 5, 6, 7, 8, 9, 10. Okay, 4, 1, 2, 3, 4, 5. There is a total 9 network. Okay, you have to design total 9 networks, and each and every networks have the different requirements. So we can easily identify this. Don't worry about this these documents. I will be providing the link. Okay, or you can easily take a screenshot and do the VLSMs. If you have any problems, like understand, if you don't get any things, if you can't understand about this one, you can easily just comment the questions that we have facing, so we can together easily solve this problem and give you the solutions from this one. Okay, This one is the problem. Okay, solve this one. In the above, I have already I have already shown how to solve these problems. Okay, I have already shown you the examples how we will be solving these problems. By taking these references, we will be solving this task 2. Okay, task 1. This is the task 1 for you. I given you the scenario based questions. So solve this, guys. I hope you have understand some information about the VLSMs, and I hope you have get some meaningful informations from this video. So guys, see you in the next video. If you don't worry, if you don't get this don't get these questions how to solve, just comment. I will provide you the solution in the next video. Okay guys, okay, see you guys, bye bye, have a good time.